Where do the electrons move the fastest? Well, according to the fourth postulate, we have this expression here, which says that the angular momentum of an orbit is equal to an integer number of h bars. And if we solve this expression for the velocity, so we want to find where the atoms are fastest, or where the electrons are fastest, the velocity of the electrons is going to be equal to nh bar over the mass of the electron times the radius. Now, h bar and the mass of the electron are constants. We have an n here, but then we also have an r, and we know that the radius also depends on n. It also depends on which energy level you're talking about. And so we need to include that as well so that we can see fully how n influences, like which energy level you're in, influences the velocity. So I'm going to put this expression in place of r here. So if we do that, we have n times h bar over mass of the electron times r, which is the same as n squared a naught. And a naught is also a constant. So we have an n in the numerator and n squared in the denominator. So we can cancel out this n with one of these. And so the velocity is then going to be h bar over mass of the electron times a naught, these are all constants, times n. So we can see that the bigger n gets, the smaller the velocity gets. And so the fastest orbit, so the orbit where the velocity is going to be the greatest, is the one where n is the least. So that's going to be the first energy level. So the first energy level has the lowest energy. So the orbit with the lowest energy, that first energy level, has the velocity being the greatest. And another way of thinking about this is if you think about the electrons as being like planets, it's the planet that's closest to the sun also that moves with the greatest velocity. So we would want to pick the orbit where the electrons have the lowest energy.